Alright, so to give you a little break from code, I want to kind of give you an idea of how you should maybe approach some problems that you'll have in your projects. So up to this point, at least in my evening of recording this stuff, I just did the UART control, the UART comms to be able to, control something on the microcontroller, and I did the PWM exercise with the LED. What happens if I want to try and combine them together? So essentially what I'm looking for is something like a UART controlled PWM. So the first thing that you have to think about with this is, well, what do I actually want from this? So start out from a high level, almost a user story. So this is almost so simple I don't even want to call it a user story, but from the user's perspective, what is this thing doing? Now, I'm not going to do the big breakdown of task by task, but just weave a narrative really quickly of, someone, I want to use, the user is going to use UART to change the brightness of the onboard LED. Simple enough, right? So think about maybe what the sequence of things have to happen. So great, we know how to use UART, we know the PWM. So when this thing is operating, what's probably going to happen here is we're going to receive something into our UART peripheral, or our UART buffer, let's say, and we're going to receive that from our device. We then want to be able to use that information to then control something in our timer module, which is the PWM, or the duty cycle. So this is basically going to translate to a duty cycle percentage, or a number. Duty cycle. Cycle. There we go. So here's an interesting question. The examples that we did were both interrupt driven. So I posit this question: do we need, as I spell these things, do we need to use the processor? Meaning, do I have to have something running in a main loop, or can I set the CPU to go to sleep and let the drivers, or let the interrupts, do the work for us? So if I take a look at this real quick, let's talk about the interrupts for a second. So each one of these things have a different interrupt routine. So for example, we have the UART interrupt routine, and we have the timer interrupt routine. And in fact, we may not even need both of these. So our interrupt service routine, our ISR for the UART, we want it to, what's our trigger? We want it to trigger whenever we receive, I before E except after C, that's a thing. We want it to trigger whenever we receive a byte over UART. Why do I know that? Well, you could control these things all sorts of ways, and this actually comes back up here. What is the user actually going to send to us? What is our user going to do? In this case, we're going to try and keep it what I know to be a little bit easier. What if they send us that we can give them 10 different brightness levels between 0 and 9. And they're going to send it to us as ASCII characters. So literally the character 0 or the character 9. Okay. So this starts to kind of frame up a little bit, or through the character 9. This sort of sets up our UART interrupt service routine. Whenever we receive a byte over UART, we want to trigger the routine. What do we want to actually do? Well, in this case, we want to let it control the duty cycle of the LED, right? So set duty cycle. Now the timer also has interrupts that we can use. Now if you're going to try and use pin 1.0, you're going to need to basically control this thing manually in terms of PWM. If we're using pins 1.6 or whatever ones have hardware, controlled PWM. In fact, we actually don't even need the interrupts from the timer. Here's why. When we say set duty cycle, if we take and remember back to when we were doing the PWM control, all that we were able to do was to control the duty cycle, we just needed to control the CCR0 register, or the 1 register. This is what I get for trying to remember everything. We set it so that when this thing was running, that the timer was going to go up and then reset, up and then reset, and then up and then reset. What we did was we said, look, this period here was set by CCR0. It basically sets how high up this thing counts. So if this was the timer 1 register, or, the current value, and this was time, or N, N number of sets. So CCR0 controls how wide it is. When we set it to reset set mode, what it would do is for our, let's extend this plot out for a second. So let me go like this real quick. So what it would do is when it would start, it would keep the pin high up to a certain point. And then, once we hit a certain value set by CCR1, we would then drop down to a 0, and it would stay that way until we hit our new period. It started over, reset, or the timer value rolled over, or hit its terminating value set by CCR0. Then it goes back up to a 1, and we begin the cycle again. We go up to a certain point, that CCR1 value. Once we hit it, it comes back down and continues. This is running regardless of whether or not the processor is on, or the UART module is receiving something. It's doing this regardless of it. So how do you think we can leverage this? So we know that the duty cycle is controlled by CCR1. What if, when we receive a value, receive something over UART, we just set CCR1 to a new value? We can do that on the fly. That's not something that's restricted to only happening when you're starting the processor up. You can control that whenever you want. So now our interrupt service routine for our UART, UART ISR, is now starting to take form. So let's pseudocode it. You're going to get some crazy code up top, but basically you say when we receive a byte, right? When we receive a byte, what we need to do is pick a value. So how are we going to go between 0 and 9? Well, the user is going to give us the characters 0 through 9. So we could actually just use something like a case statement or an if statement to see what that value is, right? So here's what I mean, is we could basically say, hey, look, do a case statement or an if statement. So select case. So for example, case statement to determine new CCR1 value. Okay. That sort of works out. So that means our code then is going to look like, you could do it as a bunch of if statements if you really want. You could do it basically also as a case select. So select case. So select based on my UART receive buffer. Based on what character I receive, right? I can then sit here and say case 0. I want CCR1 to be equal to 0. That way it's just off. case 1 needs to be, well, something. What are we going to pick? Why don't we make our lives easy? We have control over this. I haven't specified what the frequency of that PWM cycle has to be, or that signal. Why don't we make our lives easy? Why don't I make it from 0 to 900? Why? Arbitrarily. Because why not? So what's going to happen here is when we receive it, I can say, hey, when we start up, before we even start up, set CCR0 equal to 900. Cool. Because now what's going to happen is when we hit, it's going to go for up to 900 here. So now it's a pretty easy mapping, right? So if I receive a 0, set it to 0. If I receive a 1, make it 100. 2, make it a 200. It's not that bad. So UART ISR, so when we receive it, so let it now be 100. And then we can continue down to case 9 and make it CCR1 is equal to 900. Okay. I think we're done. And you may say, wait a minute, whoa, what do you mean we're done? We just wrote an interrupt routine. Well, that's kind of it. Going all the way back up to the top again, the main thing that we want our system to do is wait for a byte to be received. Once it's received, determine what our brightness should be, and then set the CCR1 register in the timer to control the duty cycle. Okay, so our code overall, we pseudocoded this the interrupt service routine. So really what this is going to look like is, maybe we're going to have some include statements. We're going to have to do a couple things here. So we need to, what functions can we run? We need to configure the UART pins. So UART pins. We need to configure the LED pins, right? So the UART pins, we need to say, hey, we want you to act as UART pins. We need the LED pin to not only say, hey, we want you to be an output, but configure it to actually talk to the timer. Okay, so we configure the UART pins, configure the LED, configure the timer pins. Okay. We have our include statements. And then I think we're good to go. Once we do all this configuration, we can actually just let our CPU sleep. As long as we also turn on the global interrupts. So that way we can actually be interrupted. So that comes into these as well. We need to make sure they're set up for interrupts and the proper things like that. So if we set up our peripherals correctly, the CPU is off, and then down to here, we're going to have our interrupt service routine for UART, which is everything that's up here. So yeah, this is like a 10-minute video or whatever, pushing a little bit longer than that, but I just wanted to walk you through kind of how to break down a problem like this. Something as simple as controlling the PWM over UART. Does it really have to be this complicated? Is it really going to take you this much time? No, but you all starting down this path of learning how to do embedded coding, it's a very different way of thinking, especially if you've done things like Arduino in the past. You may think, oh, well, it's basically, you can kind of sort of pseudocode like what we did at the end here, which is configure the UART, configure LED, so that's our setup function, and then maybe I would have a function that controls the duty cycle and stuff like that. So you're kind of thinking like that. But now that you're actually at the microcontroller level, we have all of this interesting silicon that we can work with. We can actually control the timer modules and these peripherals. And I just want to repeat again that yes, during the interrupt service routine, your processor does turn on, and it does run through the code or the instructions set in the interrupt service routine. But outside of that, it's doing nothing. It's literally off. So why don't we take what we did here down in our pseudocode, and in the next video, we're actually going to try and piece it together. And the way that I'm going to do that is I'm going to approach it from kind of where you all would come from in trying to get something to work. Meaning that we did our two examples. We figured out how to break this apart. So meaning that I look at this and say, okay, well, I need to look at how to, for controlling my brightness over UART, well, I need to learn how to use UART and how that works. And I need to look at how LED brightness is controlled. And in the other videos that we just did, you did that. So now we can actually go ahead and build the system. So why don't we go try and do that?